Hi, everyone. Welcome to the fifth episode of the Rubicon podcast. Today, we're going to talk about all things robotics. Govind Vishwesh, do you want to talk about what's been fascinating you in the world of robotics recently?
I think in the last couple of months, like a number of robotics companies announced large rounds, and I think the most popular of them, there's like a huge resurgence of interest in humanoid robots, right? And like the largest raise, of course, being uh, Figure, who the intention is basically building humanoid robots for the factory. Not obvious how exactly they're going to make money. I think one of the biggest challenges that they'll face is the fact that humans are surprisingly cheap. Human labor is very, very cheap, actually, and so like there are very few use cases in which you need like a very like a mediocrely intelligent but incredibly strong human, because you already have many of those. And so I think that's very exciting. There's also all these companies that are sort of building pure software solutions, because they think that the physical components of humanoid robots, or just robotics in general, are going to be solved in the next couple of years, which I think is very plausible. I think 10 years ago that was not the case. And, as I'm sure you guys know, OpenAI used to do robotics. They don't do so any longer. But these companies that are trying to take like pure software solutions to this, I think the way that a PhD student of Chelsea Finn, who's one of the founders of Physical Intelligence, one of these software companies, put it to me was uh, a sufficiently well fine-tuned GPT-4V is all you need to solve vision for robotics, which may or may not be true, but I think it's indicative of the way the software companies are thinking about it. There's Physical Intelligence, Covariant, and there's a few others. Right?
No, yeah, and I think I am uh, Yeah, I think I am really excited because, like you mentioned, like there's pretty much this resurgence of like these humanoid robots. Because I think like the robotics almost startups went towards these very specific use cases at first, which is pretty much like one arm going and doing like these two specific tasks and like gathering lots of value in those specific tasks and just doing them really, really well. But I think what Figure and like Tesla's Optimus and and any of these other humanoids are trying to do is like something more generalized, which is really exciting because now what you're pretty much claiming is the fact that the core manufacturing problem, which is now that that factories have become a lot more dynamic. All these massive car manufacturers or EV manufacturers, anybody is pushing hundreds of changes into these factories on a daily, weekly, monthly basis. Now these humanoids will actually be able to see, judge, and actually like dynamically change and improve their process on the basis of that, which makes me very optimistic. But then there is like this whole other question of which is like the software piece of thing, like you mentioned, which is going to be extremely hard to build. And some people are building stuff on their own. Like I know Figure, I think, is working with OpenAI, and then like other like Physical Intelligence is just building software. And there are multiple questions that are like, hey, the data wall that OpenAI ran into, which is there's just not sufficiently good data in to train these robotics to these like humanoid robots, or there are other questions around like, okay, what are the best use cases for these high quality expensive robots versus like you mentioned, cheaper labor in emerging countries, which is how a lot of manufacturing is done right now. But I think like more broadly, like the resurgence is almost like more exciting because of how broad the use cases are.
The one thing I'd say here though is like, I think the way that people used to think about robotics versus the way kind of I think we've seen kind of a significant shift in the way they think about robotics now, which is, if you look like kind of 5, 10 years ago, it was all just a question of, hey, robotics just meant extraordinary productivity, but it was like very expensive to kind of like first design and then kind of manufacture, and that kind of but the trade-off over there is you get definite kind of systems, right? Like you don't have the kind of management burden that tends to exist in most of these setups, where you, I guess, if you imagine is like kind of you're running a massive production line, you really do need to tool your, like if you have a robot that is doing things really quickly and that can be kind of reasonably kind of trusted to do its job, that is very different from a job that is kind of changing a lot, but humans tend to do kind of relatively well at those kinds of jobs. And so I feel like we kind of jumped from one end of the spectrum to now, because of all of the advances that we've had, we're kind of just saying, yeah, let's like kind of think about robotics very differently. So I think it's kind of like completely different ways of thinking about the problem itself. Just very open ended. It's like, let's just kind of like throw intelligence to the problem, and let's see how that kind of works.
I think there's an interesting anecdote there, which is when Elon was building Tesla maybe 5-10 years ago, like when they're constructing these factories, he initially started off with let's have robots for everything, and like it was supposed to be completely autonomous, right? Very quickly that failed, and like they were making rubbish cars and like losing lots of
Hmm.
scrap metal, and whatnot, right? And so go into these factories and like say like, okay, here's this robot that's doing this job with like 50% accuracy. You as a human can do that at least 60% accuracy to replace the robot with a human, right? And it's interesting to me that now we've gotten to a point where we at least think that it is possible that we can make the reverse of that change.
Yeah, and I think the other exciting thing here is also the fact that like this is also going to proliferate all of our lives on a daily basis. Like there are all these like there are a handful of companies that are also trying to build these robots pretty much for like households. Because I think I read some funny tweet which is, I don't want AI to do all the creative stuff, I want it to do my laundry so I can do the creative stuff. And I think that piece of things as well, Vishwesh, like you mentioned, like something more generalized uh, is the way robotics is being thought about now on like a very very high level. And then Govind, like you mentioned, which is like, can these robots actually get good at some mundane tasks? It feels like now, given the advancements in like generally vision models, and then along with that like models that you can use in order to control, like let's say like a humanoid robot's hands or something else of that sort, I think, and its ability to learn and replicate mundane tasks have gone a lot better. And we've seen that just from like all the public demos that these robotics companies have put out.
And again, not obvious how much of that is like reproducible on like a daily scale, right? But I think it's again it's broadly speaking very compelling. Uh, there's
I
another
would say though
interest.
that go ahead, go ahead.
Go ahead, go ahead.
Yeah, I would say though that like the general purpose nature of it kind of is what is kind of so fundamentally appealing. Yes, it's interesting to kind of like have something that you can kind of throw into a factory, because then you kind of have to care less about potentially kind of like certain forms of kind of like intense safety that you need to kind of maintain within a general factory. Then you can have the machines work for longer. You can kind of, there are kind of certain kind of levers that you can't pull in a factory that has to be managed by humans that you can pull in a factory that's kind of run more by machines. But on the flip side, I would say that the idea that you can throw kind of a general image, and all you need to do, like general image and video, and you can have a model that can reason about the world, is actually, I think, was the rate limiting factor to actually see consumer robotics, right? And we've kind of seen simple versions of consumer robotics before, which is I've got a model that can kind of move around. It's got like kind of simple sensors that can kind of figure out what's kind of around it. Roomba is a good example that we have here. Japan is a lot more robots, right? Like they actually have a lot of robots in their society,
The other night
but
I
they
was
use it for
walking
kind
through
of
the
different sorts of
Embarcadero at like
purposes. If
midnight, and I saw
they have it to kind of
a
taking care of older people, if in case someone falls, the robot can go and kind of alert medical workers, for example, to kind of go in and kind of help elderly people. And so I feel like the the reason why they were used in such kind of like simplistic kind of scenarios is because you couldn't trust that model could do anything with the information that exists in the real world. And while there's a question of, hey, how do I take the information and actually do something with it? I think if you look at like React and all of those kind of like recent, I mean, I guess recent is like 3 years ago, but I guess all of these kind of like transformer based, like think and like style approaches, I think that's basically the reason why robotics has been kind of like banging its head against kind of like the data wall and like the optimization problem for like several years at least in kind of the deep RL style setup. And the fact that you can just have a transformer just say, hey, this is what I'm seeing, hey, so this is what I should do, and then it does it, is like a complete kind of like game changer for these folks, as I understand it right now.
I think one of the very tricky things was that there was this huge emphasis on deep RL was philosophically very compelling, but the real problem is that very incredibly finicky, right? And so unless you had a
Yes.
sufficiently good base policy, like people jump to RL too quickly, I think, and they didn't have a sufficiently good
Yeah.
base policy. Now it's like GPT-4V or whatever, right? But you didn't have that before, and so you were sort of basically, you're trying to build an RPG with sticks, and it's just not going to
Mhm.
work, right? So also bullish on like all you really need for this, I think, is just fine tuning and like maybe some more RL afterwards. But like RL is just like special magic on top for like the
Yeah.
last that icing bit, right?
Yeah, and I think one of the things to talk about the data piece of things is, and from all the people who are building these robotics companies I've heard, is you just have pretty much have to put like whatever use case you have, put the robot out there and let it be in that, and like work around that use case, and you'll figure out what the edge cases are, and like that real data, like real world data, is the most helpful to actually generate more data, like, and like get your synthetic data also a lot more, pretty much make it a lot more better. I think where there is a real opportunity is, I think there is like this whole almost like form of thinking which is humanoid robots and the world is built for humans. But I believe that but I believe there is like this real opportunity in terms of newer form factors for what robots might look like, because yes, the real world is built for humans, for people with 2 arms, 2 legs, but our factories, not really, because factories right now are built by, are like have machines, and if you go to any, like if you go to China, if you go to India, anywhere where they have mass manufacturing and like lots of globalization that has happened before that, you just have these factories there where you'll only hear machines and pretty much like very few humans who are pretty much almost just taking care of a lot like the safety concerns and less on like our focus on the manufacturing piece of things. So I wonder if people are going to come out with new form factors to put out there that will help gather more amounts of data in order to train these models better, to get to better, more high quality robot, like these humanoid robots or any other kind of robots, for these enterprise use cases, at least, just because the safety concerns there are a lot, I feel like a lot better versus when you put a robot in like a household where you're dealing with real humans, you're dealing with like, just like you just have much more safety to take care of.
Mm. Oh, the other interesting thing is I think the sim to real problem was something that always sort of plagued robotics, as in like what you did in simulation was not necessarily what happened when robots were manufactured and wandering around the real world. I think, at least from what I've heard, that problem is significantly less of a problem for a number of reasons, none of which I remember. It is
But
a good question. Sorry, good, good.
no, but I think that like the simple problem, if you can solve it, solves the data problem to a large degree. But there's kind of like two takes on the data problem that's there, right? So one is, you do actually like build the robot, and then you kind of like need it to train in some way by collecting data, right? And that process is manual. But the entire one of the things that you'd expect is, we have enough data of humans moving around interacting with the real world. Why isn't that helpful? Right? Like embodiment shouldn't be that hard per se, right? Like, the models do have, why is it that it's so easy to construct a model of like, Plato talking about something, for one of these models, but why is it that hard to kind of like expect the model to make a jump for, hey, a human moves around in a world this way? I have data that shows how the real world works, how physics works. Why can't I just learn it just based off of the data? And if you believe that, you get these emergent properties, um, with scale, then you should actually build robots that are kind of some forms of biomimicry, right? Like you should actually copy the humanoid form. You should actually copy, like kind of certain animal forms, because then you get all the pre-training that you need to kind of figure out how to operate in the real world. You get that for free because you already have video of the real world. So I feel like, the way that a lot of the folks kind of right now seem to be kind of going to it is robotics is hot now. And the other thing that's hot is video. And it's kind of like both different forms of kind of just like world modeling. And if you get good video models, and like people are talking about Sora as like GPT-1, etc., like the GPT-1 of video. And so you imagine that you scale up video quite a bit, you get good models of the world, you get nice emergent properties from those models where, you can tell one of these models, hey, think about yourself. Like model can play Minecraft right now, right? Like, something like Sora can actually interpolate very well. It's all you really need to say is, and I kind of view the problem as follows, right? Like if you're Figure and you're kind of like just trying to build like certain aspects of the hardware layer, and you have like, some other system doing the software, kind of thinking, then what you really just need to say is, hey, I have an apple here. I have my hand is somewhere. I need to pick up the apple. And you just send that kind of natural language style command down to another system, and the other system architects the entire thing of, they figure out how to how to put this thing together, where it's kind of like you need the only intermediate representation that you need is text, where text just communicates everything. The other option is that you don't do text, you actually need to train everything together. And that becomes very problematic for its own reasons. So it's not clear to me which way this thing goes right now.
I think in the short term, I agree with you that, like, I mean, I think all of the figure demos thus far have been mostly a vision model. It provides instructions to the robot, right? It's a very agentic thing. So, like, I also think the better agents you have, the better quality, movement and so on, like more calibrated movement you can get from these robots. But like, I think if you want to solve that problem, the system, it is very, it seems much more difficult. I think, in my view, to expect a robot to like figure out exactly where to go and like have that sort of divorce from the vision model. I think the vision model should also be grounded, like should have some kind of grounding, so it has an understanding, it's like calibrated with its surroundings and understands what the limits of the robot's movements are, right? And if in that case, I think like end to end is actually, in the long run, is going to be the solution, as I think
Agree.
for most it always has been, right?
Agree. I think the main question though right now is, right, like imagine you just kind of like feeding kind of like different frames of video right now. You could say like, hey, go pick up the right, and it starts trying to pick up the apple, it overshoots. Then the vision model could say, hey, pick up, like pull your arm back a little bit and try picking up the apple. Like you can just shift more of the weight into the vision model. But then I suspect like the world that like the kinds of robots that we'd have there are kind of these like an equivalent of like a super brilliant person who can't walk down a street, right? So you kind of have that problem where the physical body doesn't seem to like follow from like the general intelligence that can exist. Like they can be uncorrelated in certain respects. You can just have someone who's clumsy, and you could just have like a robot that is super smart but very clumsy is not still ideal. You actually do need both in order for the robot to be like maximally useful.
Also, the other question that this conversation brings up is like, where is the value going to accrue? Is it going to accrue to the robot building companies, like pretty much the figures of the world, or is it going to accrue to the software players, which is like somewhat, I mean, it feels like OpenAI is of course like a much more horizontal solution, and they work with specific companies and like to fine tune the models, but then there is like physical intelligence that's just building for robotics. I wonder and would love both of your thoughts in terms of where you believe the value is going to accrue, because there is like definitely like the folks who are building the robots are actually going to go sell it to these enterprises or are going to sell it to the consumer. But what's going to power one of the hardest pieces of this, which is the actual movement of the robots, is going to be the software business. And this almost comes like, and it rings the same tune as like the semiconductor industry, which has like fabs, and like you also have like these fabless players. So we'd love to understand, or is it or is it both, in terms of there's going to be enough value for everybody to capture, and there are multiple massive businesses to be built here? What are your views?
I think one way to think about this is like, do you believe that these models need to be big enough that they have to be run in the cloud, or are they small enough that they can be run with incredibly low latency on device, right? And where on devices, like on the robot, right? And like, if in the cloud, then you have incentives, as OpenAI does, to just like build the best, biggest model, and every actual like hardware manufacturer, every hardware roboticist just uses you, right? But I think the view of the physical intelligences of the world is that like that's not optimal for a number of reasons. Because one is that, like, if you want to build these factories in the middle of nowhere, it's like implausible that you will always have Wi-Fi connectivity, right? uh like, one, and then
Yeah.
two, there are a lot of like incredibly low latency use cases, where like there was actually a company that OpenAI funded, and they were working Ghost Autonomy or something, for like autonomous cars using GPT-4 vision, or using the vision models, right? And that company shut down. uh, and I think the reason for that is like it's just not low latency enough, right? And there's like a number of very important, probably even like robocops, right, where having like on-device vision models is necessary.
Yeah, and I think that also comes back to the complexity of tasks, right? Because like these smaller models, and I think we've spoken about this, which is like what's Apple gonna do when like these smaller models are gonna power a lot of the easier use cases, and when it comes to harder things or harder questions, then I think like Apple showcases this by like when it says, hey, go ask chat gpt, and then they ask you for permission if they can do that. That is pretty much them saying, hey, Siri can't solve this, let's go to chat gpt. I think there's going to be some version of that in the robotics world, because if the use cases are simple enough, you'll probably have smaller models built in these humanoid robots for your specific use case. But when you go outside and it has to interact with, let's say, some sort of a dynamic process, then you end up kicking it back to the model in the cloud, which solves the harder problem and has like a much better understanding of what, like, okay, like where am I standing? What is like the actual understanding of the world around itself, and then solving the problem accordingly.
I was just thinking of a good analogy for exactly that case, right? Imagine, like, so the way Elon, for example, talks about, his gigafactories, it's the machine that builds the machine, right? And so you could think about the software layer as kind of operating similarly, where you've got a bunch of like small kind of like workers, small systems which are on device. And when problems occur, that's when the kind of bigger devices come, where that computation is complex, it's on the cloud, etc. It's kind of like the equivalent of, you've got kind of like your factory line workers. But if there's a problem in the factory line, if you want to optimize the factory line, or if you want to fix a manufacturing problem, that cannot be solved on the factory line. You need to call someone kind of like higher up in some form. And higher up in this case would be you go to cloud, right? Because that's where all the compute is. You're not going to expect to see that anyway here. Perhaps in the short term, that's not what happens. And you could also argue that if you have both sections of the stack where you own both the edge compute as well as the cloud compute, with the same software stacks, you can literally just say, hey, what is the problem over here? Like, I give you debugging functionality basically for factories, where I have a factory running. It's all kind of like the hardware gets commoditized, the software layer is where the value accrues, right? And you've got kind of like a factory running reasonably, but there's problems. And then, some companies selling you a subscription service where they're just like, look, when there are problems, you need to call us, right? Because we have another system that'll figure out how to adapt the kind of models, quickly train them in the new kind of manufacturing style that you want, and then kick it back to kind of the edge compute that you can continue running it.
Yeah, and given the complexity of this, it feels like that is going to be like to build a hardware company or like a robotics company now. That is like, of course, like margins are generally low, but now you have this like incremental large cost of like that you're paying to these software businesses, because they're also spending like so much money on capex that they have to, of course, like the only way to return that is get a return on that is from like paying charging your customers a ton of money. I wonder what the unit economics of these businesses are going to look like, given there is this whole hardware cost, which has always existed, but then there is the software cost as well, which is going to incrementally get more expensive as more and more money is getting put into these models. And I wonder if building your own models and being full stack, just the way Tesla or any of these massive companies are, is the way to make the model actually work out on like a real economic basis.
I think that is one of the reasons. Like that is the big reason to be bullish on Tesla. I don't know if like I mean FSD seems to be going well, but I think most importantly they are one of the very 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 small handful of players who has both the know-how and the need to like get like really good autonomous robots working. Uh, there's another point I was going to bring up
But
that I forgot.
we should spend a little bit of time talking about Tesla on this day, because like you can think of some version of the actual real world kind of consumer robot is like each Tesla car. Like you have the software layer is not really kind of like the main selling point right now. The hardware is like very cool, but it's one way of thinking of how do you go from hardware to software, instead of like the physical intelligence kind of esque approach, which is let's go from software and then maybe at some point we do a little bit of hardware because our models are kind of specifically good on certain kinds of hardware, right? But they seem to be really taking like the opposite approach. I don't. It's not clear to me that there are like kind of good analogs, because most of the time you can't. it's difficult to build kind of like a software section of a company from scratch. I would argue you could argue that it's difficult for hardware too. So like doing a kind of like a fully kind of like full stack company is hard in general. But like I can't think of any other analog, right? In
Yeah.
kind of any of these businesses that's doing anything like it.
Also, it you bring up this great point about Tesla being the unique spot, because like we talked about Apple a couple of weeks ago about like from like an agent perspective, but when you think about like things from a vision model perspective, Tesla has been working on like FSD for a really long time, and that like in like its most fundamental and crude sense is a vision model, and like taking that model and pretty much like putting it into Optimus, and I think like enabling and like figuring out, okay, like what are how to actually determine the movement is of course like a different problem, and I'm sure that's a really hard problem to solve as well. But like in its core, who has the most amount of vision data, who has been working on vision models for the longest time? It feels like it's like the self-driving cars companies, and like Tesla has of course been leading the way there. And I wonder if all the other businesses like the cruises of the world and other folks who, and like that is like it's interesting because when the self-driving boom was happening many years ago, many companies that were building just synthetic data for these vision models also came along. And I wonder if the self-driving companies are going to see this like new segment of revenue in their businesses, because they can use the data and the vision and the models they've built to help current businesses and current software companies building for robotics. So the same data, same model, but for totally different use case, given fundamentally they're trying to solve the same thing.
I think I think that's actually a very interesting point. I think the one tricky thing there is I know Nvidia has this huge, massive data set. Like, when Nvidia self-driving was like a big thing because they needed a self-driving division, same way everyone else had one. Uh, Collected this massive data set that basically that division is like all but shut down. I think that like no one has access to now because of PII reasons. Right. So
Mhm.
like I think that is like a like privacy for for that is one reason that I think these companies can't just go and like sell their data willy-nilly. But it seems very plausible to me that you can obviously do some synthetic augmentation, maybe sell the synthetic part or something, right? And like again, I think like seeing this is the reason that the guy who started the bot company, who was formerly at
Mhm.
Cruise, has now started the bot company, right? I'm sure he has
Yeah.
some edge there. Maybe he just has free access to the data set.
Potentially.
and, and I think we've talked about software, the hardware piece of things. I think the one piece to talk about is just like receptivity of like what that will look like in the real world. On the enterprise side of things, at least it feels like given like just like the costs at which you need to produce some like let's say consumer or like or cars or anything like that has gone down so dramatically that I think enterprises, of course, like taken up robotics and said, "Hey, this is what's going to save our business model." Whereas I think in the consumer world, it feels it feels like it's going to take a lot longer. Even if the consumer use cases are simpler, like, "Hey, vacuum my floor" or something else of that sort, it feels like consumers, given they've already seen like a lot of like almost like the emergence of these personal devices like the Alexas of the world, hear all the information that is happening in the household. Consumers have a harder time letting in more devices into their households or anything else of that sort, versus enterprises who are of course like pretty focused on like creating value for like their shareholders. But what are your views in terms of like when this all of this these like dollars that have been invested will actually translate into like real products getting in the hands of enterprises and like consumers?
I'm actually very curious about the consumer side because uh, like the question is like who is actually best positioned to build like the like to optimize the household basically, right? And it's an interesting point you bring up that like Alexa and Google Home and so on, we've been collecting these huge data sets about what humans do, which I don't think legally they're allowed to, but they have like an ear in the home, right? And so it seems vaguely plausible that they actually start off, instead of trying to convince you that this single humanoid, which may or may not work too well consistently, is the panacea to all of your household problems, is you sell like smaller devices that do like, okay, you have right now you have like a Roomba or something that vacuums your floor, right? Maybe you also have some kind of like groundskeeper esque, like mini humanoid or something, right? And then maybe you have some like housekeeper that just does laundry, right? And then you have all these like sub mini robots that don't need to do all these things. So they're not actually like taking advantage of these giant cloud models, but they work reasonably well at like the task, and they're well orchestrated by some like very intelligent Alexa in the cloud or something.
Yeah. And this comes back to the agentic like workflows that we've talked about, which is like it feels like the way intelligence and these robots are gonna work out is gonna be that there's gonna be like some sort of like a manager who's gonna be at the top, who's gonna like enable who's the right agent for what task, and that might be different robots, or that might be the same robot, but it's gonna be very much like an agentic like workflow to figure out, okay, what is the best way to solve this problem with like the most amount of accuracy. But I think there's also going to be like this whole regulatory push in terms of like what is allowed and what isn't, and I think we've seen a lot of that, of course, with the self-driving cars, and I think we're going to see more of that as these robots start taking over households, and then like just like taking over like the streets and other use cases. I think that's also going to be something interesting that's going to play out, and we'll see how that works. But I'm sure like VC dollars are going to flow in earlier to build these products, and then we're going to know what the regulatory landscape will even look like.
I mean, one of the things that I would say is, the kind of, hey, I've got a robot that does this, a robot that does this, a robot that does this, etc. That's kind of what appliances are. I've had those for like 100 years, right? Like, I've got a fridge, I've got this, I've got that. Yes, they're kind of like different, but like I'd argue that, washing machine and dryer are kind of like, very specialized robots that not that much thinking kind of encoded into it. And the flip side of that is, obviously these things are expensive, and there are large kind of like they're not really kind of extraordinarily large companies, but you could argue that if you're able to merge all of them into kind of like one set of kind of device, like that's where I think the value accrues. Where I don't need to manage like 20 different devices from like 15 different manufacturers where I've got so much competition. But if I can actually get like the one device right, that you can throw all the rest away, and it architects everything. You probably need to have like some degree of a shift in the way that we model homes as well, in order to kind of like ensure that robots are able to be like kind of useful there. But my broader expectation is, you see a lot of it that kind of like affects industry first, and then only it kind of affects the home. I'm not certain if it's going to immediately affect the home, but it like shifts very quickly. But I suspect it's going to go in that.
Yeah, and I think I would love if a robot I could just like throw my clothes in and just like the only thing it does is folds my clothes, and that'll save me like that'll save me probably like a lot of time over the week. And I think the one thing we missed, which is like the obvious case where a lot of where like definitely robots are going to be used and there are going to be like pretty much no problems. It's going to be like all of the industries where there is like real risk to life of like humans who are working in these spaces, like anything like mining related, or let's say like these oil rigs or something else of that sort. I think like there we're gonna see a ton of value accrue, just because everybody wants to like the reason those some of those jobs are really like very few people want to take them and also are very well compensated is because the risk to life. And I think all of those jobs are what robotics companies are going for first. And I wanted to mention that because I feel like we didn't talk about it in like a more direct sense, but of course like that's a huge use case as well.
And there's also the trickier use cases, because I don't know, like I feel those, I mean, they're very dangerous, right? And the reason, and because they're very dangerous, it is very likely like the first like 100 batches of robot that you send out to that oil rig in the middle of nowhere are gonna like crash and burn or something, right? So also obviously more capital intensive to like operate in like very 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 dynamic conditions, right? Actually,
Yeah,
one question I have for you, Vishwesh, is how much would you pay for that robot? And Sharia, how much
So
would you pay for like clothes folding robot? And would this be a
that's a
recurring
great
fee?
question. I think it would have to be a recurring phase. That's again this knowledge that we live in. Right? So I
I think
suspect
it's like
yes.
it's like the Whoop, right? Where like or the Aura Ring or something of that sort, which is like there is some sort of I think the Whoop doesn't have like the device is free, but then there's like a monthly cost. I think Aura does like okay, the device costs something, but like the monthly cost is lower or something else of that sort. But I think it is gonna be a mix where let's say you pay like $100 for this, like pretty much like this like robot that is a basket with like a hand and or like two hands, and like you pay another $50 every month because it's like a recurring fee. But like pretty much all you do is you put your clothes in the basket and the two hands just like fold them and put it in like a different spot. And guess what, I would be willing to pay for that, just given like uh I want to do the creative stuff and don't want to fold laundry over the weekends. But yeah, I definitely I would be willing to pay for
I feel like a lot of the money is going to exist first in industry where I can basically say, look, I can throw this robot in and I get like 2x the productivity, and it's a no-brainer. So it's just so clear that you're gonna go that. I feel like as consumers, we're just like so finicky. We want like an incredible product at like a super cheap price, and we're just you. I think you could realistically charge like a hell of a lot of money if you're able to build a product that's able to solve an enormous amount of kind of household chores. Like 50 a month is like low. I think like you should be like at least 500 a month at minimum,
For the
right?
just for folding clothes, 500 a month.
No, but I think if you bundle up like one, two different things like cleaning and folding clothes, maybe, I think you could definitely sell them for at the start of 500, and then kind of like see how you can get the unit economics.
And it's not like you're letting a stranger into your home, right? There's that.
it. Yeah. Awesome. I think that is a great point to wrap up on, which is robots that fold our clothes and why industry is gonna definitely get robots first. But thank you everyone for watching, and we'll be back next week.